Hey, this is Mr. Drogemeyer. Thanks for joining me for our Algebra 1 lesson videos. Today we are in Unit 8, looking at Lessons 4 and 5, Interpreting Solutions of Systems. So we talked in our last lesson about these systems of equations, especially as what we're looking at, and what those graphs look like. We talked about the intersection point of those lines being the solution to that system. And so we want to look today at when we compare a system of equations, determining where that intersection point is. And so in this first one here, it says determine whether the functions f of x equals negative 6/5 x plus 4 and g of x equals x minus 7 intersect at x equals 5. So we want to know these two equations. This is our system. Do they intersect at a point where x equals 5? And so there's a few ways that we could go about doing this. One way would be I can plug in 5 for x and see what I get. So if I'm looking for what f of 5 is, I'm going to take negative 6/5 times 5 and add 4. Well, negative 6/5 times 5 would be negative 6, and that would be still plus 4. And so negative 6 plus 4, f of 5 would equal negative 2. And so if they both intersect at that where x equals 5, then when I do find g of 5, it should also equal negative 2. So I plug in 5 for x, and 5 minus 7 does equal negative 2. And so we would say, yes, these do intersect at x equals 5. Another way that I could do this is I could graph those two equations. And so I have these graphed in Desmos, f of x, g of x, and we're looking at when x equals 5, there's that point, 5, negative 2. They do intersect there. So you can plug that value for x into each equation, do it that way. You can draw your graphs and check it that way. So either way is an acceptable way to check that out. All right, so let's do a couple more here. This time asking if the functions f of x equals negative x plus 3 and g of x equals negative 3/4 x plus 4, whether they intersect at x equals 4. So again, we can plug in positive 4 for x. So that would be negative 4 plus 3. So f of 4 is going to equal negative 1. Do the same thing for g of x. So g of 4 is going to be negative 3/4 times 4 plus 4. Negative 3/4 times 4 is negative 3. And negative 3 plus 4 would be positive 1. So we do not get the same value this time. So they do not intersect at x equals 4. Again, if we check our graph, so here I've graphed those two equations. At x equals 4, you can see here's the one that's at 4, 1. Here's the one that's at 4, negative 1. So these actually are going to intersect when x equals negative 4 at negative 4, 7. All right, and then our last one, these two equations, do they intersect at x equals 2? Again, I could plug in 2 for x and do it that way. This time I'm just going to look at my graphs. So I do have these graphed here. X plus 3, negative 2x plus 9. It was asking, do they intersect at x equals 2? And we can see here that they do intersect at that point, 2, 5. And so our answer here would be yes, they are intersecting at that point, 2, 5. All right, so that's how we can use those solutions of systems. Appreciate you taking the time to watch. If you do have questions, please let us know. Thanks. Have a great day.